to be able to deliver on that, the expected user experience there, it's really important to not just deploy a Kubernetes cluster, but to have a solution in place that can automate the deployment of Kubernetes clusters throughout their life cycle as needed to be able to support developer teams and isolation between different applications and teams and users and so on. And so Tanzu Kubernetes Grid is a core capability. When you install TKG, installs a management cluster. That management cluster then handles the ability to receive those simple API calls or commands. Say, I'll deploy a new workload cluster for a new Kubernetes cluster. And these Tanzu workload clusters are just Kubernetes clusters that are available for, say, a developer team to be able to use. And it uses a technology called Cluster API, which is a project of Kubernetes itself, to be able to provide really this type of architecture where we can have that management Kubernetes component, and it actually uses Kubernetes and some extensions on Kubernetes that are open source to be able to deploy workload clusters on that in that automated fashion across multi-cloud environments through being an open standard. Okay, let's take a look at Cluster API. And so we know Kubernetes is a great environment for managing, deploying containerized applications and providing the orchestration needed to really optimize that environment. But actually, the creators of Kubernetes have been on record, saying, hey, Kubernetes is really great at orchestrating containers, but it's actually not just containers. It's really good core methodology for orchestrating, just about anything. And so there's been a very common practice in the industry to extend Kubernetes. So we'll use the same exact methods that it does to manage its core object types, pods and deployments and replica sets, but to be able to add additional object types, additional custom resources, and extend the API and the data model to be able to manage other things the same way. So to be able to deploy Kubernetes clusters, Kubernetes normally runs pods and containers, whereas Kubernetes clusters themselves are x86. Generally they're typically virtual machine environments. So you need to deploy a virtual machine, and Kubernetes doesn't deploy virtual machines typically. And so that's where the Cluster API provides extensions onto Kubernetes to allow object types and introduce object types into Kubernetes to be able to deploy virtual machines and then manage and monitor the configuration and lifecycle management of Kubernetes clusters specifically. And so where Kubernetes core object type is a pod, Cluster API adds machine. And much like replica sets, we have machine sets. And deployments in Kubernetes kind of map to machine deployments with Cluster API. And we add additional, since this is a very purpose-built deployment, like when you think about a pod isn't purpose-built, right? A pod, a replica set, a deployment, those tell me that it's some containerized application. Really, the purpose of Cluster API is to not just deploy machines, but to deploy them really specifically optimized and built for Kubernetes. So a Kubernetes cluster can then be used to create and help and meaningfully lifecycle manage Kubernetes clusters that it creates. And so we have these additional cluster and control plane objects and custom resources to be able to define all the configuration attributes that are needed for the workload clusters that the management cluster will create. And this is so Cluster API is a open source Kubernetes project right now, implemented and used as a core part of Tanzu Kubernetes Grid. Okay, now let's take a little visual look at how Tanzu Kubernetes Grid works. So first, we'll start with a vSphere cluster, and this could also be a other supported IaaS. And so if you think, if you on your premise you may utilize a vSphere ESXi, and it provides virtual machines for you. There's essentially, if you're working with Amazon or Azure, they have essentially a very, very similar comparable set of capabilities where you can go to those services and ask for a virtual machine to be provisioned on a virtualized hypervisor environment. And so whether it's vSphere or whether it's Amazon EC2 environment or a Azure virtual machine, how it works is essentially the same. And so we'll show the example on vSphere. And so we have TKG provides a really simple wizard-driven installation app where it provides just a couple forms through web interface where you can fill out some information. It gathers a lot of information for you, so to help you prevent how much you have to go research and type in, it'll just connect to your existing vSphere environment and gather a lot of the information about it dynamically. So you run through that simple installation process, and it will go deploy a set of VMs, control plane virtual machines, worker node virtual machines. It is a Kubernetes cluster, but it is specific type of Kubernetes cluster, right? It's the management, and it has certain attributes and services running on it to facilitate the services that are needed for deploying clusters and providing services for this location. And so once you have this management cluster in place, at that point you have the API, you have TKG CLI, and you can say TKG create cluster and hit enter right on the CLI. You can provide, of course, some attributes. And then as you do that, in a few minutes, it'll go and create a workload cluster. And that does, provides the services to centrally aggregate the data to help with the ongoing support, troubleshooting, visibility, lifecycle management of these clusters that get deployed at this site.